Okay, today we're going to talk about what happens with fractions or dividing with complex numbers. So when I'm dividing two complex numbers, say, I'm just making some numbers up here. Let's say we have 3 plus 2i, and I want to divide that by 4 plus 3i. Okay, so what we're going to do is we're going to what's called rationalize the denominator, because I don't want complex numbers in the bottom. Okay, so the way we're going to rationalize the bottom so that we don't have a complex number is we're going to do what's called multiply by the complex conjugate. Okay, so we're going to use the complex conjugate and we're going to multiply. And first off, we better figure out what a complex conjugate is. So a conjugate is when you're going to take the same thing, but you're going to take this plus and you're going to make it a minus. So if I have 4 plus 3i, its complex conjugate is 4 minus 3i. If I have 2 minus I, its complex conjugate is 2 plus I. If I have 3, let's not do that one. If I have negative 3 minus 4i, its complex conjugate is negative 3 plus 4i. So you notice the only thing that changes is the symbol right here. That's what it means to be a complex conjugate, is that those two symbols stay. What's out front, whatever it is, it just stays, it goes along for the ride. Whatever's next to the I goes along for the ride. It's just the symbol between the real portion and the imaginary portion is going to switch. And something really special happens when you multiply these two numbers together. So let's use the simpler example, this one. And let's see what happens when we multiply these together. So we got 2 minus I, and we're going to multiply it by 2 plus I. Okay, so multiplying these two together, I don't know why that looks like a T. Let's try that again. 2 plus I. There we go. So we're going to multiply these together. We use the distributive property. So we got 2 times 2 is 4. 2 times I is 2i. And we'll do it again on the bottom side. So negative I times 2 is negative 2i. And negative I times I is negative I squared. And this is what's special by using one positive and one negative, is these middle terms cancel out, because 2y minus 2i is 0. So I'm left with 4 minus I squared. And you should already know, if you've been watching earlier videos, that I squared is by definition negative 1. So this is 4 minus negative 1. Double negative becomes a positive, so this is 4 plus 1, which is simply the number 5. So when I multiply a complex number by its conjugate, we have this very interesting result. The answer is a real number. It's the number 5. Okay? And that happens all the time, so that's why we want complex conjugates. So the point of multiplying this denominator by the complex conjugate is that it will no longer be complex, it will now be a real number. So we're going to go ahead and do it up here. So the complex conjugate of 4 plus 3i is 4 minus 3i. And that's what we're going to multiply. But we also know that we're not allowed to just multiply the bottom of a fraction. It's going to actually change it. So we have to do the same thing to the top. Okay, so we're going to multiply top and bottom by the same number, which is 4 minus 3i. And we're allowed to do this because anything divided by itself is always the number 1, unless it's 0, and then that's a special case. But these are not 0, so we're allowed to do it. So anything divided by itself is 1. So 4 minus 3i divided by 4 minus 3i is the number 1. So we're allowed to multiply by 1 and not change it. So if you ever wondered why we could do that, that's why we can do that. So let's go ahead and multiply this out. So we're going to multiply tops and bottoms. This is just like any other fraction. So if I say have 1/2 and I'm multiplying this by 3/4, you're going to multiply the tops together. 1 times 3 is 3, and we multiply the denominators together. 2 times 4 is 8, and then last step is going to be check to see if it can be simplified. Okay, that's always the same steps, and we're going to do the same thing up here, just it's a much more complicated problem because I have all these complex numbers involved. Okay, so we're going to multiply top and bottom. On the top, let's go ahead and put the parentheses here so we don't remember, forget we have to do it. We're going to go ahead and use the distributive property. So just to make it a little easier, I think I'm going to rewrite this with colors for you. So we're going to do the top is going to be 3 plus 2i. And then we got 4 minus 3i. That's what we got to multiply on the top. And on the bottom of our fraction, we're going to do 4 plus 3i. And we got to multiply that by 4 minus 3i. And let's go ahead and put our fraction bar back in there. Oh, for some reason I got white. It doesn't work so well. There we go. All right, so that's what we're going to multiply. Okay, so I just rewrote this. I extended the fraction bar across. Since it's multiply, you can, because those are all multiplied anyways. So we got 3 plus 2i times 4 minus 3i, and on the bottom we got 4 plus 3i times 4 minus 3i. Let's go ahead and do the top. Just like we've been doing forever, we're going to do the distribute property. So I got 3 times 4 is simply 12. 3 times negative 3i, well, 3 times, we got a minus symbol. 3 times 3 is 9. And then I got an I. So 3 times 3i is going to be negative 9i. And then I got to go back and do the same thing with the other two. So I got positive 2i times 4. 2 times 4 is going to be 8 with the I, because I have one I. So 4 times 2 is 8 with the I. And then lastly, I got 2i times negative 3i. Positive times negative is negative. 2 times 3 is going to be 6. And of course, I times I is I squared. All right, so we got some middle terms right here that we're going to clean up. Going to go ahead and write them up top here. So we got 12 minus 9 plus 8 is going to be minus 1. So that's just minus I. And then we got minus 6i squared. And of course, I squared is negative 1. So negative 6 times negative 1 is going to be positive 6. So this is the same as 12 minus I plus 6, which is going to equal 12 plus 6 is going to be 18 minus I. Okay? On the bottom, so let's change the color and do the bottom. And I should have gotten a bigger page. But that's okay. We'll make it work. On the bottom, I got 4 plus 3i times 4 minus 3i. So we got 4 times 4 is going to be 16. We get minus 4 times 3 is 12, so minus 12i. And then doing it the other way, we get positive 12i. And lastly, 3i times negative 3i, we get a minus. 3 times 3 is going to be 9. And then I times I is I squared. And as we set up on purpose, the i's are going to cancel. So we end up with 16. Negative 12i plus 12i is 0. So minus 9. And remember, I squared is still negative 1. So this is going to be the bottom of our fraction. We get 9 times negative 1 is going to be negative 9. So we end up with 16 minus a negative 9. Minus a negative becomes a positive, so this ends up being 25 on the bottom. So I'm going to go ahead and rewrite that down here so we can see it. Okay, so this is all gone. Okay, so what I have up there is 18 minus I on the top, and I have 25 on the bottom. Now we want this to be as a complex number, so this one's going to have fractions involved, and that's okay. I think I said earlier that it didn't, but maybe that was a different video. We can have fractions, so we're going to multiply, split this fraction up like we've done before. So we're going to split this up into 18 over 25, and then I got the minus symbol, and over here I got, since it's not here, there's a 1, so I'm going to have 1 over 25. And then we always put the I outside, because remember this is supposed to be A plus BI, and the minus symbol is okay, because this is plus a negative. So here's our A, that's our real part, and here's our B is negative 1/5. Okay, so whenever you see it in fractional form, just split it up, and we're going to go ahead and leave it just like that. So our complex number, when we divided these, is going to be 18 over 25th minus 1 over 25th I. Okay, so if you have any questions, go ahead and ask. You might want to watch this video a couple of times because there's a lot to rationalizing the denominator of a complex number when you have this situation. But you should end up with a complex number coming out that's in the form of A plus BI form like this one is. So if you have any questions, please make sure you ask. And as always, this is going to take practice. This is probably the hardest thing that we will do with complex numbers right here.